Question 1. Through the lens of system efficiency metrics, how should a geothermal technician evaluate the performance of a residential ground source heat pump GHP system compared to a high-efficiency air source heat pump in a mixed humidity climate with seasonal soil moisture variation? Only compare EAR values because they directly reflect energy use in geothermal systems. B. Compare COP and EAR values alongside soil thermal conductivity, ground loop design, and real-time performance data. C. Focus solely on SEER values because they're more commonly listed by manufacturers. D. BTU output per square foot as the sole determinant of performance. Answer. Correct answer. B. Explanation. While energy efficiency ratio EAR and coefficient of performance COP are essential, evaluating GHP performance requires a deeper understanding of system-specific and site-specific factors. Unlike air source GHPs rely on consistent subsurface thermal properties, soil moisture, type, loop configuration, and installation depth influence heat transfer and must be considered with COPEAR metrics. To HVACR guidelines and ASHRAE 90.1 standards, evaluating performance must incorporate seasonal changes and system behavior under varying loads, not just manufacturer ratings. Question 2. Demonstrated by a recent system commissioning project Ortega is testing a newly installed closed-loop horizontal geothermal system in clay-rich soil. She notices low flow and fluctuating loop pressure during purging. What is the most likely root cause and appropriate action? A. The pump is oversized and she should throttle the flow. B. Air is trapped in the loop and she should continue purging using a high-flow flush cart. C. The soil has high conductivity, so no purging is necessary. D. The antifreeze mixture is too viscous and must be diluted immediately. Answer. Correct answer. B. Explanation. Fluctuating loop pressure and low flow during purging are typically caused by trapped air, especially in horizontal loops where slopes and multiple direction changes increase air retention. HVACR flushing guidelines require the use of a flush cart capable of producing equals 2 feet sec flow to remove air. Clay-rich soils don't directly affect air entrapment but influence loop heat transfer post-commissioning. OSHA 1926.651 also requires monitoring pressure in closed systems during testing to ensure safety. Question 3. One might argue that a primary advantage of vertical closed-loop systems over horizontal ones is their adaptability in constrained urban lots. What other significant technical advantage do vertical systems offer in terms of heat transfer? A. Reduced pipe length requirement due to soil expansion. B. Increased thermal conductivity due to deeper access to stable temperatures. C. Enhanced natural convection from groundwater movement. D. Higher installation speed with no drilling equipment needed. Answer. Correct answer. B. Explanation. Vertical systems access deeper soil strata where temperature remains more stable year-round, leading to consistent thermal conductivity and more predictable heat exchange. While groundwater may help, it's not guaranteed, and natural convection is minimal in sealed boreholes. The need for drilling equipment is a disadvantage, not an advantage. According to ASHRAE and HVACR, vertical loops are ideal where surface area limited and geological stability at depth supports high efficiency. Question 4. When faced with intermittent compressor shutdowns on a geothermal unit in a commercial building, ISTA observes short cycling and a high-pressure fault code. The ground loop pressure and temperatures appear normal. What should he investigate next? A. Check the return air temperature to verify adequate building load. B. Increase the system's loop flow rate manually. C. Add more refrigerant to correct low suction pressure. D. Replace the expansion valve immediately. Answer. Correct answer. A. Explanation. Short cycling and high-pressure faults can result from inadequate building load or poor airflow across the indoor coil, leading to reduced heat absorption. This causes refrigerant pressure to rise. While loop conditions are normal, return air temperature and air distribution problems should be evaluated first. Per ASHRAE guidelines and manufacturer diagnostic protocols, indoor airflow is a critical component in system performance and should be evaluated before altering refrigerant charge or component replacement. Question 5. In the modern context of environmental impact, what is A key ecological advantage of geothermal systems over conventional fossil fuel-based heating systems when installed and operated correctly. A. Increased ozone layer degradation due to refrigerant types used. B. Complete elimination of all energy consumption during peak load. C. Significant reduction in greenhouse gas emissions and carbon footprint. D. Lower soil nutrient content due to loop field excavation. Answer. Correct answer. See explanation. Geothermal systems, especially ground source heat pumps, operate on electricity and exchange heat with the earth, not via combustion. This leads to drastically low HE emissions compared to fossil fuel systems. The EPA recognizes geothermal as one of the most energy efficient and environmentally clean HVAC technologies available. While refrigerants still pose environmental risks, Section 600 of the Clean Air Act regulates handling. Proper loop installation has negligible impact on soil nutrients. Question 6. Considering the evidence from a multi-zone geothermal installation, ISTA is tasked with integrating a desuperheater to provide domestic hot water. IWR must he ensure for optimal efficiency and functionality of the system? A. The desuperheater is only enabled when the unit is in cooling mode. B. The domestic hot water tank is placed upstream of the buffer tank. C. The desuperheater circulator pump is interlocked with the compressor operation. D. Bypass valve is always open to maintain flow at all times. Answer. Correct answer. C. Explanation. For a desuperheater to function efficiently, it must operate in sync with the compressor as it reclaims heat from the refrigerant during active operation. This is controlled through interlocks. Placement of the OAB depends on system design, but operation timing is crucial. HPEP and DOE best practices recommend integrating control logic for optimal performance and to prevent unnecessary pump cycling, which would reduce system lifespan and increase operating costs. Question 7. To illustrate this point, during a drilling operation for a vertical geothermal loop, Mr. Alvarez encounters a high water table that begins flooding the borehole. What is the correct procedure to address this condition safely and ensure compliance with environmental standards? A. Pump the water into a nearby storm drain to proceed quicker. B. Stop the drilling, evacuate the borehole, and call the EPA. C. Use approved containment methods to redirect water and continue drilling with sealed casings if required. D. Drill a secondary borehole immediately to relieve hydrostatic pressure. Answer. Correct answer. C. Explanation. Encountering a high water table is common during drilling. Per EPA and state environmental guidelines, water must be managed on site using containment and redirection systems to avoid contaminating surface or groundwater sources. Storm drains are prohibited due to potential contamination. Sealed casing may be required depending on the aquifer's sensitivity. OSHA 1926 Subpart S and HPA guidelines require proper handling of groundwater during borehole construction to ensure both safety and environmental compliance. Question 8. With respect to system diagnostics, what does a sustained low pressure reading in the geothermal refrigerant circuit most likely indicate, assuming flow rates and air delivery are within acceptable parameters? A. The reversing valve is stuck in heating mode. B. There is a partial refrigerant restriction or undercharge in the system. C. The compressor is running too fast and needs a speed controller. D. The loop field is oversized and rejecting too much heat. Answer. Correct answer. B. Explanation. A sustained low pressure condition in the refrigerant circuit often points to a restriction in flow, e.g. clogged metering device or an undercharge. Proper superheat and subcooling measurements must accompany pressure readings to verify. Oversized loops or reversing valve faults would cause temperature control or mode issues, not necessarily low pressures. EPA 608 regulations emphasize the importance of accurate diagnosis before adding refrigerant to prevent unnecessary emissions and system inefficiency. Question 9. Among the various installation challenges, what is the most common cause of loop field underperformance in sandy soil conditions despite proper system sizing and equipment selection? A. High electrical resistance in soil. B. Excessive shading from nearby structures. C. Poor thermal contact due to backfill compaction issues. D. Inconsistent refrigerant metering due to ambient temperatures. Answer. Correct answer. C. Explanation. In sandy soils, poor backfill compaction leads to air gaps around loop piping, drastically reducing thermal conductivity. Even with well-designed systems, heat transfer efficiency depends on good soil contact. HVACR standards require thermal grout or engineered backfill to ensure performance. Electrical resistance and ambient temperatures have minimal impact in buried loops. This highlights the importance of soil thermal conductivity testing and quality installation practices over theoretical sizing alone. Question 10. In light of recent developments in energy codes, how should a geothermal technician ensure compliance when retrofitting an older property with a modern geothermal system in a jurisdiction adopting the latest code version? A. Ignore duct leakage standards as long as the system is geothermal. B. Focus only on SURIA metrics as the building envelope doesn't affect compliance. C. Conduct full manual J-load calculation and ensure duct sealing and insulation meet code. D. Retrofit the loop field only and keep the existing air handler. Answer. Correct answer. C. Explanation. Modern energy codes such as the HVACR require a holistic approach, not just equipment efficiency. Duct leakage, insulation, and sizing per manual J. ASHRAE endorsed are crucial for compliance. Retrofitting with geothermal systems doesn't exempt from broader building performance standards. Maintaining old ductwork without testing violates code and may result in performance losses. Technicians must work in coordination with code officials to meet full compliance. Question 11. In comparison with traditional air source systems, Mr. Barrett is considering a geothermal installation for a hospital renovation project where consistent indoor temperatures are critical. He also needs to minimize long-term operational costs and ensure quiet system operation. Which of the following characteristics best supports his decision to choose geothermal? A. High supply air velocity and increased air mixing for temperature control. B. Passive ventilation through open loop exchange without compressors. C. Stable thermal output with minimal seasonal variation due to ground temperature consistency. D. Higher seasonal maintenance demands that lower compressor wear. Answer. Correct answer. C. Explanation. Geothermal systems utilize the Earth's relatively constant temperature to provide stable heating and cooling, especially useful in applications like hospitals where consistent thermal comfort is vital. The Earth's temperature, typically between 4.5–7.5 depending on depth and region, allows geothermal systems to avoid performance swings seen in air source systems. According to ASHRAE and HVACR Guide, geothermal HVAC units are quieter, more efficient, and have fewer external components. Passive systems are rare and not suitable for large buildings. Question 12. By evaluating soil composition during a pre-installation site assessment is Calderon determines that the location contains a high percentage of fractured rock. What is the most likely technical concern and how should she proceed to ensure optimal loop field performance? A. Excessive moisture retention will prevent proper loop heat rejection. B. Fractured rock allows improved convection and requires no grout. C. Potential air gaps reduce thermal contact, requiring high conductivity grout to fill voids. D. Heat loss will be too high, so she must reduce loop length. Answer. Correct answer. C. Explanation. Fractured rock formations often contain air pockets or irregularities that inhibit direct pipe-to-earth contact, reducing heat transfer efficiency. HVACR best practices require high conductivity grouts, e.g., bentonite with silica sand blends to fill voids and establish consistent thermal conductivity. Grouting ensures loop stability, structural integrity, and performance. Simply extending the loop without addressing poor contact won't solve the underlying problem. Excess water is not inherently problematic unless combined with erosion risk. Question 13. The question remains whether a closed-loop geothermal system installed in a coastal area with high saline groundwater exposure requires special material considerations. Which of the following approaches best addresses long-term durability? A. Use bare copper piping to maximize conductivity. B. Apply internal PVC lining to all circulation pipes. C. Specify high-density polyethylene HT with fusion welding to resist corrosion. D. Design the system as an open loop to take advantage of available groundwater. Answer. Correct answer. See explanation. In corrosive environments like coastal region, HDE pipe is the industry standard for closed-loop systems due to its chemical resistance and thermal performance. According to expert guidelines, HDPE pipes joined by butt fusion provide leak-proof durable joints that last decades. Copper corrodes quickly in saline water. PVC-aligned pipes are not standard for geothermal loops. Open-loop systems in such environments risk fouling and salt deposition and typically require more maintenance. Question 14. Taking into account thermal dynamics, which of the following would most likely cause erratic compressor cycling and energy inefficiency in a ground source heat pump system with a correctly sized loop? A. Excess loop length and reduced pipe friction. B. Improperly located thermostat or faulty indoor temperature sensor. C. Installation of auxiliary electric heat upstream of the superheater. D. Use of antifreeze with a higher freezing point than required. Answer. Correct answer. B. Explanation. A thermostat placed near a heat source, e.g., direct sunlight or supply vent, or a faulty sensor can falsely signal the compressor to start and stop frequently. This leads to short cycling, reduced system life, and efficiency loss. This is not a loop design issue, but rather a control and placement issue. According to ASHRAE 55 and Manual S guidelines, thermostat location must represent average conditions for proper cycling. Antifreeze selection matters for protection, but not directly for compressor cycling. Question 15. In response to an unusually high system pressure reading during a heating cycle, Mr. Daniels suspects a flow issue in the ground loop. Which of the following is the most appropriate next step to confirm or rule out his suspicion? A. Measure pressure at the compressor suction line. B. Check loop temperature differential and flow rate using a flow meter. C. Inspect the duct system for air leaks. D. Increase the thermostat set point to reduce pressure. Answer. Correct answer. B. Explanation. Pressure fluctuations in geothermal systems can often stem from improper loop flow. Measuring the temperature difference between supply and return lines, along with actual flow rate, e.g., using a flow meter or manufacturer-provided charts, allows accurate diagnosis. A low DT or low flow indicates restrictions or pump issues. ASHRAE and ICHPA recommend these diagnostics as first steps. Compressor suction pressure relates to refrigerant issues, not loop hydraulics. Question 16. From a practical standpoint, why is fusion welding the preferred method of joining HDE geothermal pipes in both vertical and horizontal closed-loop installations? A. It allows for the use of low-cost adhesives in wet conditions. B. Fusion welding creates a joint stronger than the pipe itself, eliminating leaks. C. Welded joints can be disassembled easily for inspection. D. Fusion welding is only necessary in horizontal loops, not vertical systems. Answer. Correct answer. B. Explanation. Fusion welding, particularly butt fusion and socket fusion, met HDE pions and joins them under pressure, forming a homogeneous bond that is often stronger than the pipe wall. This ensures durability and prevents leaks over decades of operation. HVACR installation standards require fusion joining for long-term reliability. No adhesives are used and joints are not designed to be disassembled. Both vertical and horizontal loops require this technique to meet code and manufacturer warranty requirements. Question 17. As evidenced by recent service logs, Mr. Knight's commercial geothermal system is experiencing low heat output during peak winter months. After verifying the heat pump is functioning correctly, what is the most probable cause from system-level perspective? A. Ground loop temperature is dropping due to undersized loop fill. Air handler speed is too high and over-delivering heat. C. Too much refrigerant was added during summer maintenance. D. The thermostat is not set to emergency heat mode. Answer. Correct answer. A. Explanation. If the ground loop is undersized for the building load or soil conditions, the system will extract more heat than the earth can replenish, causing loop temperatures to drop seasonally. This leads to lower efficiency and reduced capacity. Emergency heat mode should only be a backup. Overcharging with refrigerant affects pressure but not loop side energy. According to HVACR design criteria, proper loop sizing based on soil conductivity and heating load is essential for sustained winter performance. Question 18. under the assumption that a geothermal system must be commissioned for a LEED certified building, which verification step is required to demonstrate energy efficiency compliance and proper performance. A. Visual inspection of all pipe joints. B. Completion of manual duct layout and pressure report. C. Detailed loop flushing, pressure testing, and thermal response testing (TRT). D. Submission of manufacturer warranty card to the LEED review board. Answer. Correct answer. C. Explanation. LEED certification emphasizes documented system performance. Flushing ensures proper loop flow. Pressure testing confirms system integrity, and thermal response testing evaluates loop field heat transfer capacity. These steps are aligned with HVACR commissioning standards and must be documented for LEED credits under E. Energy and atmosphere. Visual inspection alone is insufficient, and warranty submission is unrelated. Certification. Question 19. In contrast to traditional above-ground HVAC systems, which of the following represents a unique troubleshooting challenge in geothermal systems that technicians must be trained to address? A. Fan motor replacement due to filter clogging. B. Circuit breaker tripping from outdoor condenser overload. C. Flow restriction or leaks in underground loop piping. D. Humidistat failure in ventilation control panel. Answer. Correct answer. C. Explanation. Underground loops are inaccessible without excavation and present unique diagnostic and repair challenges such as detecting flow restrictions from kinks, air pockets, or leaks. Special tools like ultrasonic flow meters or pressure drop analysis are required. Unlike conventional systems, loop performance is affected by subsurface conditions. Fan motors and humidistats are common across HVAC systems and unique to geothermal. ASHRAE and HRConquer recommend periodic loop performance audits for long-term reliability. Question 20. The most significant aspect of routine maintenance for a geothermal heat pump system operating in a multi-zone commercial facility is A. Replacing buried loop pipes every 5 years to ensure conductivity. B. Calibrating zone thermostats and verifying proper valve sensor function. C. Draining and refilling the loop with clean water monthly. D. Replacing antifreeze every 6 months regardless of condition. Answer. Correct answer. B. Explanation. Multi-zone systems rely on precise control to distribute heat and cooling where needed. Thermostat calibration and sensor verification ensure zones operate as intended. Most antifreeze solutions are rated for multi-year use and only require annual pH and concentration checks. Draining loops regularly can introduce air and contaminants, violating HVAC maintenance standards. HDE loops designed to last over 50 years and do not require frequent replacement. Question 21. The development of a geothermal system in an area with known karst topography presents unique engineering challenges. What critical factor must Mr. Halstead prioritize during vertical borehole drilling to avoid safety hazards and long-term system failure? A. Minimize grout depth to reduce environmental contamination. B. Maintain constant high-pressure flow through the loop to collapse voids. C. Assess and mitigate risks of sinkholes or void collapse by conducting geophysical surveys. D. Backfill the loop field with native soil immediately after drilling. Answer. Correct answer. C. Explanation. Karst regions feature soluble rock formations, e.g. limestone, that can result in unpredictable voids and sinkholes. Borehole collapse or groundwater contamination is a significant risk. HVACR and local environmental codes require geotechnical and geophysical surveys before drilling. Proper casing, grouting, and risk mapping are essential. Minimizing grout depth or relying solely on backfill is unsafe and non-compliant with EPA and OSHA 1926.651b subsurface hazard requirements. Question 22. Upon closer examination of a multi-family geothermal system, Mr. Drayton observes inconsistent supply air temperatures across various zones despite balanced airflow. What is the most likely cause of this issue? A. Excessive refrigerant charge in the system. B. Loop field length varies significantly between zones. C. Malfunctioning zone control valves or temperature sensors. D. A faulty high limit switch is disabling the compressor intermittently. Answer. Correct answer. See explanation. Inconsistent temperatures despite balanced airflow typically point to control issues like malfunctioning zone valves or faulty temperature sensors. These components regulate zone-specific operation, and if they fail, the zones won't maintain set points. High-limit switches protect the compressor, but their failure would shut down the system completely. According to HRConquer system guidelines, zoning systems must be calibrated, verified during commissioning and maintenance. Question 23. Among the various antifreeze solutions used in geothermal systems, why is propylene glycol often preferred over ethylene glycol in residential installations? A. It provides better thermal conductivity than ethylene glycol. B. It costs significantly less and is easier to recycle. C. It poses lower toxicity risks, making it safer for potential groundwater exposure. D. It doesn't require pH adjustment or corrosion inhibitors. Answer. Correct answer. C. Explanation. Propylene glycol is the preferred antifreeze in residential geothermal systems due to its low toxicity, especially in the event of an accidental leak into potable water or groundwater. While ethylene glycol has better thermal properties, its toxicity makes it less desirable for residential use. EPA guidelines and HVACR standards promote safer alternatives in domestic applications. Both antifreezes require regular monitoring for pH and corrosion inhibition. Question 24. To what extent does improper loop purging impact system performance in a horizontal geothermal installation on a sloped site with multiple elevation changes? A. It increases the loop pressure, improving heat transfer rate. B. It causes air pockets that restrict flow and reduce heat exchange efficiency. C. It enhances turbulence, which increases thermal conductivity. D. It reduces compressor runtime by lowering refrigerant pressures. Answer. Correct answer. B. Explanation. Air pockets from incomplete purging can block water flow and create uneven thermal exchange in the loop. In sloped installations, gravity can trap air in high points, requiring proper flushing with equals 2 feet sec velocity as per HVACR standards. This directly impacts system efficiency and compressor performance. Increased loop pressure without flow is ineffective, and turbulence due to trapped air doesn't help heat transfer. It hinders it. Question 25. A key distinction between horizontal and vertical geothermal loop configurations relates to A. Horizontal loops always require antifreeze. Vertical loops never do. B. Vertical loops have consistent thermal performance due to stable ground temperature at depth. C. Horizontal loops provide better efficiency in sandy soils regardless of location. D. Vertical loops are only suitable for small residential properties. Answer. Correct answer. B. Explanation. Vertical loops reach depths where ground temperature is more stable year-round, resulting in predictable performance, especially in regions with wide seasonal air temperature swings. Horizontal loops are more influenced by surface conditions and weather, and their effectiveness varies with soil type and moisture content. Both configurations may require antifreeze. According to ASHRAE and HVACR guidelines, system design should consider available land, soil thermal conductivity, and project budget. Question 26. When analyzing loop field performance in a newly built school, Mr. Stevens notes a rising trend in loop entering water temperature during cooling season. What does this most likely indicate? A. There is a blockage in the refrigerant expansion valve. B. The system is undersized or the loop field is not rejecting heat fast enough. C. The compressor is cycling off due to low load conditions. D. The air handler fans are overperforming and removing too much humidity. Answer. Correct answer. B. Explanation. A rising loop entering water temperature during the cooling season suggests heat is not being effectively dissipated into the ground. This points to either an undersized loop field or a site with poor thermal conductivity. HVACR design criteria require that ground loops be engineered to handle peak loads without long-term thermal buildup. Problems with the compressor or air handler would show different symptoms. Question 27. During the process of retrofitting a commercial building with geothermal, what is the most critical factor for determining whether an open-loop or closed-loop system should be used? A. The total number of occupants in the building. B. The utility provider's rebate program. C. Local water table availability and environmental permitting. D. The brand of geothermal heat pump selected. Answer. Correct answer. C. Explanation. Open-loop systems require a reliable and clean groundwater source and must comply with strict environmental discharge regulations. If the site lacks adequate water or permitting is restricted, a closed-loop system is preferred. The number of occupants and equipment brand may influence sizing or selection, but not system type. EPA, state water management authorities, and HVACR mandate environmental review for open-loop feasibility. Question 20. Focusing specifically on maintenance, why is checking the concentration and condition of antifreeze solution in a closed-loop geothermal system critical during seasonal inspections? A. Antifreeze enhances refrigerant cycle pressure for better performance. B. Incorrect concentrations can corrode loop components or cause freeze damage. C. Antifreeze eliminates the need for compressor oil. D. The solution prevents bacterial growth in refrigerant lines. Answer. Correct answer. B. Explanation. Antifreeze concentration must be appropriate for local freeze protection. Too low and freezing may damage pipes. Too high and fluid becomes too viscous, reducing system efficiency. Additionally, pH and corrosion inhibitors must be within specifications to prevent internal degradation. HVACR maintenance guidelines recommend annual testing of antifreeze parameters. Antifreeze is unrelated to refrigerant, oil, or bacterial control in closed loops. Question 29. Contrary to popular belief, geothermal heat pump systems do not produce free energy. Which of the following best describes how geothermal systems still require energy input? They rely on fossil fuel combustion to circulate fluid. B. Electricity is needed to operate pumps, compressors, and fans. C. External heat strips are always active for auxiliary heating. D. Solar panels must be installed to complete the system. Answer. Correct answer. B. Explanation. Geothermal systems use electricity to drive components like compressors and circulation pumps. Even though they harness ground heat passively, they're highly efficient, often achieving COP values over 3 or 4, but not self-sustaining. Auxiliary heaters and solar panels are optional, not mandatory. HVACR and DOE classify these systems as renewable assisted HVAC, not purely renewable. This distinction helps manage consumer expectations regarding energy costs. Question 30. When evaluating the merits of geothermal integration with hot water generation, which of the following represents a major operational benefit of incorporating a superheater in residential applications? A. It operates independently of the heat pump and reduces electric consumption year-round. B. It adds a second compressor that replaces the need for a water heater. C. It uses waste heat from the compressor to assist in heating domestic hot water. D. It overrides the main heat pump control to prioritize water heating over space conditioning. Answer. Correct answer. C. Explanation. A desuperheater captures waste heat from the heat pump's refrigerant cycle to preheat water in domestic hot water tank, improving system efficiency and reducing electric water heating load. It only operates when the compressor is running, typically in cooling mode when excess heat is available. This is supported by HVACR and manufacturer best practices. It's supplement, not replacement, for conventional water heating.